In this video, we are going to learn about Mysql keys. Now, the word key itself means something very important, as we say in a key point or a key role played by someone somewhere. I'm just going to quickly draw a table and then try to show you what the key is. So there we go. This is our table. These are our columns. And I want to have one of the column act as a key. Now what does that mean? Now in MySQL we are going to see three types of constraints: unique constraint, a primary key constraint, and a foreign key constraint. When I say constraint, let me spell it out. Constraint means restriction. And what are we restricting? We are going to have restrictions on columns and rows about what values they can or cannot have. And why do we have these restrictions? Is because we want to have a good structure for tables. We cannot have a table with a lot of redundant information. We are just going to look at the tables that we already have in our database. Show databases. My spelling is wrong, it's not going to work. Show databases. I'm going to use the database called company that's already created. Let's see, show tables. I have employees and okay, I have employees table. That's good enough. I'm going to see what is part of employees. So let's start from employees. I have these many employees. Now I'm just gonna do it for fun. Insert into employees values 106. Name is Ibrahim. Salary is 3000. Joining date is exactly March 10 as it is there, and gender M. If I look at the database table employees, now I have two rows that have exactly the same row, same column. Two rows with exactly same values in every column. This is redundant information. You don't want to store information of one employee at multiple places. That's why many database tables have some column act as a key column. Now a key column can be primary key or a unique key or a foreign key. We are going to look at it one by one. So now we are going to create a table, which is a demonstration table that can, and in that table we are going to have two columns. One column will be a primary key and one column will be a unique key. So let's create a table. Create table. I'm just going to call it prime unique. It's the name of the table. Now the first column I'm going to call id underscore pk for primary key. I want it to be integer and I will say primary key, comma. Then I'm going to say id underscore unique int. I'm going to say unique. Oh, my bad. I will retype it. Create table prime unique id underscore pk, which is my int primary key, then id underscore unique, which is my int unique. 0 was affected. Now let's describe this table and see what it reveals. Describe prim underscore unique. The fun. Now IDPK, this is my column which is of key primary, and ID unique which is of key UNI, which is a short for unique. Now let's try to insert some values in it and then we'll realize what's the meaning. It says actually default null both places, but look at the null column. For PK it says no, and for unique it says yes, which means you can have a null value for a column that is unique key, that has a unique key constraint, but you cannot have a null value for a column that has primary key. Again, for a column with unique constraint, you can have a value that is null, but for the column with primary key constraint, you cannot have null as a value. You're gonna see the example immediately. Insert into this table called prim underscore unique values. I will try to insert null comma null. Very clear and useful error. Column ID underscore PK cannot be null. Can ID underscore unique be null? Let's check it out. I'm going to say 1 comma null. Yay! So it can be null. 2 comma null. If I do now select star from prim underscore unique, then I can see that ID unique has 2 nulls. Now when the value of the unique column is null, the uniqueness is not guaranteed because this null is same as this null essentially. But what won't be allowed is if you have 3 comma 3 and then you have 4 comma 3, then it will give us an error saying duplicate entry 3 for key ID unique, because ID unique is the column which is a key column with a unique constraint, which means 2 rows cannot have the same value for that column. If I select star from prim unique now, I will have 3 rows, 1, 2, 3, and ID unique is 3, which means there cannot be any other row that contains the value 3 in the ID unique column. Primary key, for primary key, same thing applies, which is I cannot insert now another row with the primary key 3. I'll have very similar error message, except my key is now primary, not ID unique, which is duplicate entry 3 for key primary, meaning that I cannot create another row with the same primary key value, which is 3, because I already have a row that contains the value 3 for IDPK column. Clear? I think the difference between the primary key and unique should be clear by now. Because the unique constraint allows null values, primary key does not allow null values, and because of this, primary key is the column that usually identifies the row uniquely, and that's not the case with the ID unique column. Now we are going to make this constraint additionally for the table employee. If I describe employees table now, all the fields, that is all the columns, they allow the value null, and the key says key column is empty, which means there is no primary key. If I select star from employees, I get this. I'm going to try and add another column to it first, just to show you the demonstration of alter command. So I will do alter table employees, add column. Let's say employee has number, name, salary, joining date, gender. I'll add the column reports to, which is also int. and default is null. Well, null allowed is already there, so that's it. What I did with alter command is very different from update. With the update command, you update the individual values of some row. With alter table, you can add a column to the existing table. So now if I select star from employees, I will get another column which is reports to, and because I did not mention not null, all the existing rows get the value null for this particular column. Now similarly, I can also alter table, but instead of adding a column, I can add a constraint. Now this is also part of the syntax, so to just make it explicit, you can also write it like this, so that you know that add constraint is something SQL understands, whereas employees is just the name of the table. So we are going to alter table. Which table? Employees table. We are going to add constraint. The constraints will have a name, and I'm just going to name it real nicely, PK, which is a primary key constraint. Say PK underscore EMP is a primary key constraint, and now I have to say which columns are part of this primary key. Now here is the thing, a primary key can contain more than one column, because sometimes one column is not sufficient to identify the row uniquely. But in our case, employee number is going to be enough to identify the row uniquely. Now this is really fun. When I try to alter table and try to add constraint, this applies to the rows that are already present in the table. Now, while adding the constraint, MySQL server tells you that there is a duplicate entry 106 for key primary. See, because there are two rows with the employee number 106. Now I want to see if this actually worked or not. So describe employees. The primary key is not added. See, the key column here is empty for employee number. So what I have to do is first remove this entry, make sure that all the entries have unique employee number, and then add this constraint. So I'm going to delete from employees where employee number equal to 106. That poor employee is gone. Now I have all the rows with unique employee number. Now I'm going to alter the table, add the constraint primary key MP primary. Now I have without error. I'm going to describe the table employees. Ta-da! Look what changed here. When I describe table here, I have employee number can be null and there is no key. Now employee number cannot be null because it's a primary key. Now let's try to insert into employees values, and I'm going to try something with 101. It's some salary with some fake joining date and some fake gender and some reports to some another number. Just wanted to show you the error. I cannot insert the value into employees because there is already a row with employee number 101, and now employee number is my primary key, which means this column the values will be unique for every row. So no two employees can have the same employee number. No two rows can have the same value in the employee number column. And I already have a row with 101 as the column value for employee number. That's why I cannot add another employee with employee number 101. So that's a primary key, and that's how you add the primary keys to the existing table. So now we cover unique key constraint and for primary key constraint. Now let's see what is a foreign key constraint. Now foreign key constraint can be explained actually along with another concept that we are going to cover today, which is of relationships. So when there are relationships between tables and we want to represent them, then we are going to need this very special mechanism to represent it. Now inside the company, our database, we have employees table. Now we are going to have another table called as department table. So let's create the table departments. I'm going to say now dept no, which is department number int. I'm just going to say now this is my primary key. By default it is not null. Then department name. Then I have let's say manager, which is varchar that's the department. Why I'm trying to create this table is because I want to show you the example of relationships. Now relationships in tables, between tables, are of three types. Could be one-to-one relation, one-to-many relation, or many-to-many relation. Now this many-to-many relationship we will cover a bit later. The example of one-to-one relation is very simple, like one user has one account, for example, in the company. So one user can have exactly one account, or one user can have exactly one record. One user can have exactly one email. Now I'm talking about one particular company or one particular organization. Of course, you guys can have multiple Gmail accounts or Yahoo accounts or whatever you like. But for a company, one user will have exactly one account, like unique account. So that's example of one-to-one relation. For one-to-many relation, we are going to see the example of the department. So I didn't finish the create table because I want you guys to think with me, and then we'll create the table together. So now you guys know what is a unique key. You guys know what is a primary key. Now if I consider tables employee and department, what sort of relationship is there between them? So there is employee here and here is department. I know these are not columns, but now imagine that they are already tables in themselves. So we could draw tables like here. These are the names. So one employee, how many departments can he be part of? Only one, right? But one department can have multiple employees. So one department can have many employees. If I want to represent it in a database, how should I do it? Let's say there are different departments, like there is a sales department and there is a development department. Now sales department has multiple employees. Shall I make different tables? It feels really odd, right? So there is this table for sales, then I have employee number 1, employee number 2, employee number 3, and so on, and here employee names and so on. Developers might have their employee number starting from 101 and then 102 and so on. But it would make sense to have all employees in one table, right? So we could have all the employees in one table where these employee numbers would be 1, 2, 3, 4, dot, 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 then 101, 102, and so on. So all the employees will be in the same table with their names, ID, salary, and so on, and additional column for department. And to have this department column, only thing we need from the department column is the ID of the department. We don't need to repeat, let's say, the name of the department or the manager of the department or their budget or any other information, right? Why can't we do the other way around? So think about adding employee inside a department. What I'm doing now is I am adding department ID inside employee table like this. If I do the other way around, if I have the ID or the number of the employee adding into the department table, what might happen is one department with some name, with some manager has employee number 1. The same ID, same name of the department, same manager also managing employee number 2. Same ID, same name of the department, same manager also handling employee number 3. So I repeat this information a lot of times. And if the department table has multiple columns and all these columns are repeated too many times, so again it's too much redundant information. That's why when you have one to many relation, you have two different tables for both. So one table for department, one table for employees. This is the many side. One department has many employees, and then you use the key from the one side of the relationship. So this is the one side of the relationship, which is department. One department has many employees. So this is the one side of the relation, which is department. Many side of the relation is employees. Then the rule is that you use the ID of the one side of the relation, which is the department in this case, and use that as a foreign key inside the many side of the relation. It means if there are many employees in one department, then every row of the employee will borrow a column from department. And why is it called foreign key? Because it's not the key of the employee. So department ID is not the original column for employee table, but this column is borrowed from department. And when you borrow something, it means that thing already exists in the other table. So if there is a department ID called 101, then you can use 101 as the value of column inside employee table. In simpler English, employee has to belong to certain department. If the department does not exist, employee cannot work in that department. In your homework for the last week, you had country and city. This is again example of one to many relation. One country has many cities. Then in the city table, you have a foreign key for country table, from country table identifier, which could be country code. So if country code is the primary key of the country table, then that is used as a foreign key inside the city table, which means city cannot exist without a country. Similarly, employee cannot exist without a department. Employee must be in some department because one department has many employees. Now let's enforce this one over here. Now create table departments. Some syntax error. Here varchar. Let's see. Create table departments. Department number int primary key. Department name. Department name should be varchar. And then manager. Manager is actually not even necessary. I'm not going to write the manager. Less columns the better. Demonstration. Okay, there we go. We have it. Now let's insert some values. Insert into values. Let's try departments from 5001. Sales 2002, development, and let's write marketing. Now if I describe departments, then I can see it is a primary key, cannot be null, good. Now but this is not used in the employees. Now again I have to add the column in the employees which is department number. So I will do something like alter table employees, add column deptno which is int. Now this is okay because I haven't associated the constraint yet. Describe employees, I have just another column now, department number. Now I'm going to add the constraint and say that this department number is not ordinary column. This column should be borrowed from another table. So alter table employees, add constraint. Now it is FK, which is short for foreign key. It's not a rule, it's just a convention. I'm using this for constraint as a convention, so I'm going to use foreign key constraint from deptno is department deptno. I hope the syntax is correct. What I mean to say is the department number, department deptno column is from the table department and the column deptno. I have a problem here. Let's see, I'm not going to waste time here. I'm just quickly DuckDuckGo foreign key constraint add alter table. It's the syntax. Okay, I was missing references, so I just have to write here references. It should work. Nope, and the brackets. Fail to open the reference table department because maybe my name is wrong. Yeah, it's called departments, not department. There we go. So alter table employees, we add a constraint fk department. The constraint is foreign key. This constraint is on which column? Department number. This column references the table departments and the column department number. That's how we add the foreign key constraint. Just want to see select star from employees. Now all of these are already null because that's the default value. Now select star from departments. See 5001 to 3. Now let's try to update employees, set deptno equal to 5001, where let's say employee number equal to 101. So Dima works in sales. See how I established that connection? Update employees, set department number 5001, where employee number is 101. This is allowed because I'm just setting this column value to be 5001. Now if I try to use any number that is not present in the department number table, then I'm going to get an error because of the foreign key constraint. Because the foreign key constraint is the restriction on the column department number of employee table, which says that this department number references the department's table department number, which means if the department number does not exist in the department's table, then I cannot use that department number inside employees table. And that's precisely what the error says. Cannot add or update a child row. Which row? The row that contains the employee number 102. Why not? Because a foreign key constraint fails. And what is that constraint? It says, see, company dot employees, which means the database company, the table employees. Constraint is fk underscore department, which we just created. And the constraint says that it's a foreign key constraint on the department number column, which references department number from the departments table. And the foreign key constraint is about if the department number does not exist here, then it will not be able to possible to add the department in the employee. But of course you can add the department that already exists. So select star from employees. I have Jalal working in department number 5002, which I don't know which department it is, but I'm just gonna now just use random numbers here. 3, 1, 4. Now this one is funny. See, update employee, set department number equal to 5003 where employee number equal to 103. Now it says query OK, but it says 0 rows affected. Why? Because there is no row that contains employee number 103. So if it cannot find the row, this is still a success message, or there is no error if you can't find it, because there is no constraint that is violated. There is no problem. If you cannot find something, then it is as good as the update was successful. So if there was employee number with 103, it was possible to set the department number to 5003. But if the employee number was not found, then the update was still successful. So you don't get the error. This is sometimes misleading, but with the error, with the information message, it is clear that no rows are affected. While when you do update employees with department number 5001 for employee number 104, which exists in the table, then it says one row affected and one row matched and one row changed. Now if you check select star for employees, of course 104 Ceylon has a changed department number. Now let's also change department for Humbing and Ali. 5002, 5 and 5003 for Ali. And I'm going to remove funny because it's really a weird employee number. So delete from employees where employee underscore no equal to this weird number, and select star from. There we go. It's a beautiful table. And now who has the most salary? CLN 5000. Okay, the reason I wanted to do it is because I want to now fill up also the reports to column. So now I will do update. Again, employee set reports to equal to, I will say, let's say 104 where employee number equal to 101. So Dima reports to Ceylon. Employee does not exist because it's employees. Okay. Also Jalal reports to Ceylon. Now I want to see Humbing reports to Dima, which is 0, and Ali reports to Jalal. Let's see, select star from employees. No, I think I made a mistake. So yeah, 101 reports to 104, 102 reports to 104. No, that's not what I want. Reports to 104. Yeah, that's right. And now reports to 102. This should be 107. Okay, that's what I wanted. Now because I wanted to cover next topic, which is, where did it go? It's not connection.js. Material. Okay, so we did cover one-to-many relation, primary key, foreign key. Well, yeah, composite key we haven't really covered, but I'll tell you in a minute. Many-to-many we haven't really covered. Okay, I wanted to cover joins, which is very useful concept. Now let's say I wanted to have every employee that works in the department sales. Now this information is kind of easy to find, but also not easy to find. There are multiple ways to find this information. If you select star from departments, then you will see, oh yes, sales department number is 5001. Then I need to find all the employees who work in department 5001. Now you can do it easily because the tables have only 5 rows and 3 rows. You can just look at them and tell me the answer. But if the tables have hundreds or thousands of rows, then it's not easy. Then you need to develop a logic. And I just spelled out the logic for you, that you need to check first the department number, get the department number from the department's table, and then use that department number inside employees table to match, and then find out the names. So you can do something like this: select DEPTNO from departments where DEPT name equal to sales. If you do this, what you get is department number 5001. Now but I'm going to solve this one with something called as subquery or a nested query. So selecting a department number from department is my nested query or subquery, which is going to give me the number. But I am interested in employee name from employee table where department number is in this table. And I hope this should work. Ta-da! So what's happening here? I'm using something called as nested query. And the nested query is select department number from departments where department name is sales. So I'm interested in all the departments that have the name sales. It will be exactly one department. It will give me this result as the table. Now because it's a table, you can go through these results. If you remember from JavaScript, you use the results or rows in the callback function, which will give you all the rows of the table as the result. So you get 5001 as the result of this subquery. Now you compare that when you are trying to find out employee names from employees where department number in is in this set. This set means this table. So you select all the employees from employees table where department number is in 5001, which means you are comparing basically employees who have the department number 5001. So this is one way of solving this query, which is a nested query or a subquery. We are going to do the same query by using something called as joins. So let's do it. Select employee name from employees. Now I'm going to use alias, and I will tell you in a minute why, as E, comma, departments as D. So I'm going to identify now employees table with capital E, departments table with capital D. And why? Because I want to compare the department number column, which is the same name in the departments as well. I want to match the department numbers from employee table to the department table, and I want to make sure that the department dot dept name equal to sales. Let's see if this gives the correct answer, then I will go in detail about this one. Tada, I get the same output. Look at these two queries. They give me exactly the same output. The first query is easier to understand, I know. You just type a subquery, gives you the department number where the name is sales, and then you compare that with the department number of the employees table. This is more tricky. It's called the query with the joins. Now I will show you what happens when you join two tables, and then we will see all the types of joins. But remember, these are the type of queries you will write a lot. Select star from employees. There are 5 employees, we know. It also tells you in the end 5 rows in the set. Okay. Now you can also do this. Select count star from employees if you just want the count of number of rows. Now what will be the output of this command? I like to ask this, but unfortunately you are not in front of me, so I will guess that you have guessed something wrong, because that's the fun part for me. So employees table has 5 rows and departments table has 3. So some of you might guess the output would be 8, but the output is not 8, and that's the point where I get to laugh in the class, but online I cannot do much of laughing. And the output is 15, because when you use comma inside select clause after from, this comma and another table represents a cross join or a vector product. Now the vector product is something to do with mathematics, where you have a set A and a set B. Now if a set A contains 3 items 1, 2 and 3, and a set B contains 2 items A and B, then the vector product means this: 1A, 1B, 2A, 2B, 3A, 3B. So all possible combinations of two sets. So 1 pairs with A and B, 2 pairs with A and B, and 3 pairs with A and B. That's what vector product is. So we are employees with 5 columns, 5 rows, and departments with 3. In total I will have 15 rows. You can also see the output, how it looks like. Employees, comma, departments. See, I get all these 15 rows. So basically, first employee, who is Dima, I get all her columns: 101, 101 name, salary, joining date, gender. These columns remain the same. Reports to, everything remains the same. What changes is the last three columns, which is department number and department name. So what you see here, 5001, 5001, 5001. Now these 5001 are from the employees table, and then you have department number 5001, 5002 and 5003. Unfortunately, it's in the column. Okay, let me try and make it a bit bigger. Maybe I can show you. Yeah, okay, great. At least I can show you in one screen now. So this department number over here, where my mouse is now, is from the department table, and that's why over here in this query I do e.depth.no equal to d.depth.no, because in the where clause I'm choosing particular rows from the table, right? So when I combine these two tables, employees and departments, I want to choose rows where first department number is sales. I want to choose department name sales, and the department number should match with this department number. Now this department number is from the table department, and this department number is from the table employees. I just join them together, but I still want to match them because Dima works only in department number 5001. She does not work in department 5002 or 5003. So only the row which contains the department number 5001 should be matched with Dima. Similarly, for Jalal, even though the department number sales is matched, the sales department has the number 5001, which is not same as department number of Jalal. So this will not be matched. But again, for Ceylon, department number sales matches, and also the department number of the department table and department number of the employee table where row is of Ceylon, it matches. So that's why we get the output Dima and Ceylon. Again, for Humbing and Ali, the sales department number does not match with the department number where they're working. So is that clear? It's the example of the inner join. Well, sorry, it's example of the comma join or cross join, it's called. Now we are going to look at the inner join. For inner join, you have to say explicitly what kind of join this is, and now we are going to see the example of that as well. So select, let's do this, employee underscore name from employees as E, and then you have inner join. Then you have another table, in this case it is departments as D on, because it's a syntax. When you have inner join, you explicitly mention which column you want to do the inner join on. And when you do inner join, you find a column that is common to both tables. In this case, it is going to be department ID. And then you just say on e.deptno equal to d.deptno. And then I'm going to say where d.dpt name equal to sales. Ta-da! Same output, exactly same output. Some people, for some people, this is easier to follow than this query, where we just do from employee comma departments. So this comma join or a vector join, and this is inner join. Now these two things are exactly the same, except the syntax is different. And with the inner join, you have to explicitly mention on, and then you have the condition, like which condition you want to use to join these two tables. But the output will be exactly the same. So that's a comma join or a vector join, and this is inner join. Now we are going to see very interesting one, which is the self join. Self join means you want to join the table to itself. The reason why I added the column reports to for the table of employee. Now I want to see who is manager of whom. So basically I want to select employee. Let's say I'm going to say e1 dot employee underscore name comma e2 dot employee underscore name. Now you will ask what is e1 and e2. I'm going to use aliases. Employees from, let's say, employees as e1, and I'm going to use inner join again here, or I can just use comma also. Let's see, from employees as e1 inner join employees as e2 on. Now I want e1 dot reports to should be e2 dot employee number. So now just imagine this employees table next to each other. So for Dima, I want to display Ceylon. So the reports to column of Dima should match with employee number column of Ceylon. Now if these tables are next to each other, this is E1. So the reports to column of E1 should be employee number column of employee E2. Let's see what's the output now. Ta-da! There we go. Dima, the manager is Ceylon. Jalal is the manager is Ceylon because Dima is reporting to Ceylon. Jalal is reporting to Ceylon, and Hambing is reporting to 101, which is Dima, and Ali is reporting to 102, which is Jalal. But who is Ceylon reporting to? She has 5,000 as salary and she is reporting to nobody. How is that? Let's make this output a bit better. IPCC employee name and manager. It's just beautification of the output. Employee and manager, but I still don't see the row for Ceylon, who, if I just look at select star from employees, Ceylon is actually reporting to nobody, so I should also see that. Now that's where left join and right join become important. So for left join and right join, they are reverse of each other, so if you understand one, you understand the other. Now we are doing left. When you are doing left join, just remember this kind of Venn diagram, and Venn diagram is something you do in math, where you basically draw circles, and it's like the intersection, this is the union, and so on. So this is A and B, this is the intersection. This is like a Venn diagram. Now when you are doing left join from table A to table B, what you do is you take everything from table A and the intersection. That's left join. If you're taking right join from B to A, then you take everything from table B and the intersection. Now this is an interesting case because I'm combining self join with left join, because I want to print all the employees. Let's say E1 is the employee table here and E2 is the manager, because I realize that some of the employees might not have managers. So I'm still going to print them. So only difference I have to make here is now to have the keyword left join in my query, like this. Instead of saying inner join, I will say left join, and my output is this. It's only one word change. Because I say left join, I'm going to print all the employees, no matter what, if they have managers or not. Because for CLN, the reports to column contains 101, right? So this condition over here, E1.reports to, it's not going to match with any employee number, because there is no employee number that has value null. Why? Again, employee number is the primary key, which cannot be null. So every employee must have an employee number, but reports to can be null. So I'm still printing the value of for CLN for manager, even though it is null, because I'm using left join. So I'm using left join and printing information from the table A, even though some of the information is not really matching with table B. Now in our case, A and B are both the same tables. This is the employee table. So I will try to draw it here with to give better examples. So let's see, new screen, create, yeah, and I will just draw not all columns, but I will draw only two columns. So employee table, and these are aliases. E1 and E2 are the aliases. Both tables, let's say, they have same columns. I'm just going to use columns that are important for the query, which are employee number and reports to. We'll say REPY as a short for reports to. So employee number and reports to. Now looking at our table, 101 and 104. Because we are joining these tables, 101, 104. So all the rows are same because we are joining same table to the same table. It's one of other tables. 104 is reporting to null. Again, 104 is reporting to null. Now because I'm using left join, A, this is A and this is B, I'm going to print E1.employee name for all the employees. So I'm going to print employee names of 1, 2, 3, 4, 5, all of them, because it's a left join. I will print all of them. Then I will print employee name as manager only for those employees where I match this condition, E1 dot reports to equal to E2 dot employee number. So E1 dot reports to 104, E2 dot employee number. So whoever has employee number 104, that person CLN will be printed as a manager of 101. Similarly for other rows, and for 104, even though we don't have a match because null is not employee number of any employee, we will still print it because it's a left join. Right join is exactly analogous. So if you want to write the same query with the right join, you just write E2 and then E1, you just swap the aliases and it will work exactly. So now let's we cover joins, inner, self, right and left joins. Out of aggregate functions, we have covered count already, which basically counts number of records. You can also do this, for example, we find number of female employees, count star. You can also do sum, but then to do the sum, you need to have a column that is numeric. So this is sum of all the female employees' salaries. This is sum of all the male employee salaries, and so on. If you want to verify it, you can just do select star from employees, and you will see Jalal and Ali has 3,000 and 3,000 as salaries, and their sum is 6,000. So this sum is working as expected. There are other aggregate functions, you can try it out yourself. Okay, distinct is also a very useful keyword. It returns basically distinct values or unique values. It can be used with aggregate functions because sometimes you have multiple values returned from the same query and then you want to use distinct. Now let's say from employees table we want to let's say select count of distinct deptno from employees. Right. Distinct DPT, no, I have a problem there. Is my spelling wrong? I don't think so. Let's see, this is correct. Company.count does not exist. Is it a space? Oh yeah, whew. There is no space after count apparently, it doesn't work. Should not be space. Without space it will work. So if I just count number of departments from employees, I get 5. But of course there are only 3 departments if I just count unique departments. So if I want that, then I use the keyword distinct. Then I get exactly 3 departments. I can also type it as unique departments or just DPT count. I get the department count. So that's how you use the distinct. There are 2 more clauses that are important and you might have used it for the homework already, group by and having. So group by statement, it does what it says. It groups by certain column. And let's see an example here. Now we have this table, so let's start from employees. And now we are going to group by gender, let's say. Group by gender. So see, I get an error. Expression 1 of select list is not in group by clause and contains non-aggregated column employee on employee, which is not functionally dependent on columns in group by clause. This is incompatible with SQL mode. Now this error message is extremely informative, but we don't know what is functionally dependent, and we don't have time to discuss functional dependency because it is really advanced database theoretical concept where you have dependencies between columns. That's called functional dependency. And I'm going to try to translate it into very simple words. So it's basically group by is often used with aggregate functions to group the result set by one or more columns. So you cannot select star because you want to group by gender, but what do you want to group by? Let's say you want to sum of salary. Then this is something you can do with a group by gender. And then you can also print that column basically. But you cannot print a column that is not grouped by. That's when you get the error. So it says expression 1 hash 1, which is number 1 here, of select list is not in group by clause, and group by clause is for the column gender. So if you are grouping by gender, then you cannot use other columns in the select, and if you do, then you have to aggregate that, because it says employee number 1, this expression 1 is not in the group by clause and contains non-aggregated column company.employee.employee no, which is not fully functional on columns in the group by clause. If you have a column that is dependent on gender, then this would make sense. Now let's try to aggregate it and see if we can make this error go. There we go. So you need to either aggregate that column, or that column should be dependent on the group by clause column. So, but employee number is not dependent on the gender. So you cannot use employee number as it is, but you can use employee number with the aggregate function, because this makes sense for this group. You can count the number of people grouped by the gender. So you know how many employees are of gender F and what is sum of their salary. So reason why you do group by is you want to find some information by some groups. Sounds pretty intuitive, right? So let's start from employees. There are only two groups based on gender now here, so that's all right. Okay, now you can also use, if you want to filter further from this, then you cannot use having, you cannot use where, you have to use having. If you want to filter the rows given by group by, then you say having, and then again for having you only have these 3 columns now, you cannot use random columns. You can say having, let's say, some salary greater than 7,000, I think. Yeah, there we go. So here you have to use condition that is one of these columns, because you are only selecting these columns. You cannot here say here employee number equal 101. You will get error again. Or not equal to. See, unknown column employee number in having clause. Now you will get mad at me because employee number is a valid column in the employees table, but it is not valid in the having clause, because having clause only chooses columns from the group by. And now we are grouping by gender, and we are selecting count of employees, gender, and sum of salary. So I can use only one of them as the condition. So I can use the condition sum of salary, which is one of the columns I'm selecting over here. So that is about having clause. Let's see if we covered everything I wanted to cover. We haven't covered domain modeling yet, but we will, and also many-to-many relation. We'll do it in a minute. But we have done primary key and foreign key. I know we haven't done composite key, so we are going to do composite key now. Then we are going to do many-to-many relation, because they are both related. and then we'll do domain modeling. We have seen joins, we have seen aggregate functions, we have seen distinct, group by, and having. So let's do composite key and many-to-many relation. Okay, now the example of many-to-many relation is we have employees, we have departments, and we have, let's say, we have project. So we have one employee, employee table, it has employee number, then we have projects. We already have departments, so let's forget about departments now, because we know department has many employees, it's a one-to-many relation. Now because there is no point in asking, I will just tell you that project and employee have many-to-many relation. Why? Because one employee can be working on multiple projects and one project can have multiple employees. Now we cannot put one key into the other or this key into that key, because we have to repeat the information anyway. So employees may have 100 other columns, project may have 100 other columns, joining date, manager, budget, and whatnot. And if one project, let's say project is 501, 502, and so on, there are these projects, and if one project there are 100 employees, then I will have to write 100 times information of all the employees here, which is not good. And same, if I put project number here, I have to also do it multiple times. So instead, the solution is to create a relation table. It's called relationship table. On this relationship table, it's a very special table because it contains foreign key from both tables, employee and project, ENO and PNO. And this particular table has a very special primary key which consists of 2 columns, and such a primary key is called as composite key, because it's not single, it's composite. It's composed of 2 different columns, because employee number 101 can work on project number 501, and employee number 101 can also work on project number 502. At the same time, there could be employee 103 who is working on project 502. So project number or employee number cannot single-handedly identify the unique row in this particular table. You need both employee number and project number to uniquely identify the row. Now let's implement this. Show tables. We have these tables. Now create table projects, proj_no int primary key, project name varchar 50. We don't need anything else now. And create table emp_proj. Just say now ENO int. I will not say primary key now. I'll just say ENO is int, then PNO is int. Then we will need something called as foreign key. So ENO is not just int, it is references. It is foreign key references employees employee NO. Let's see if this works. Then I have PNO, which is also int, and foreign key which references projects proj.no. Then I have primary key which is eno comma pno, and that's the end of my table. Now I have error. What is foreign key references syntax? Do I have to write explicitly? I hope not. No. Let's see where I made a mistake with this. Okay, let me check. Many to many relation table foreign key. Continue with cookies, please. Oh, it's MySQL many to many relation foreign keys. I should have stored the syntax somewhere, but okay, this is it, I think. The syntax is absolutely alright actually. Foreign key constraint when creating table. W3 schools should not be same. Yeah, okay, here we go. Foreign key references, this is correct. We have, oh no, we have to write it explicitly. Okay, let's do it. What can we do? Not null. Let's just write it here. Create table emp proj eno int not eno int not null eno int not null, and we'll write constraints one by one. Constraint fkpno, which is a foreign key constraint. Foreign key, which is pno, references projects proj.no. Constraint fkeno, which is also a foreign key. eno, references employees employee underscore no. Then I have primary key, which is eno comma pno. Should be end, should work. Great. The syntax can be a bit tricky. I don't remember the syntax all the time, but now we have it. So this is the table emp proj with 2 columns only and with lots of constraints. Let's describe this table. Employees, sorry, emp underscore proj. There you go. See, you get a lot of more new information now. eno and pno, it says pri, which is a composite primary key. and select star from projects. Let's insert into project some random values. We'll start a project name from 9001. Star Trek is my project. Oh, values 1002. Game of Thrones. I have two projects. Select star from, these can be code names, so it doesn't matter the names of projects. Employees. Now I'm going to insert into emp proj values 101 comma 9001. It's possible. 102 is also working on 9001. 104 is working on 9002, and 105 is also working on 9002. Again, I cannot type something now here which is not present in the employee table. It will give me the same error as before with foreign key constraint fails, because FKENO, this foreign key constraint says that the employee number must exist in the employee table before it can make it into the EMP proj table. Because in the EMP proj table you have employee number which references employee number of the employees table. So if the employees table does not contain the employee number 100, I cannot add it in the EMP proj. Similarly, if I try to add some other project number, it will give me the error with the PNO constraint fail, because the project number must exist in the projects table. So that was about many-to-many relations and a composite primary key. Now the last topic that we need to discuss is where is it? Callback hell, no. Yeah, here we go. Entity relationship diagrams. I'm not sure if this should be part of the homework or not, but I'm just going to explain the diagram here anyway. So entity relationship diagram is basically used to do domain modeling, and domain modeling is very fancy word now, but it's good to know why people do it, because it's good to have a perspective of the project and what kind of tables to create and so on. So when people say domain modeling, they want to basically understand the problem and convert the problem into a database. That's what domain modeling is, because when you are doing modeling, you want to, it has nothing to do with taking your clothes off and showing off your body. This modeling is software modeling. So when you decide how the data should look like, how the data should behave, what should be the key, what should be the foreign key, and so on, that's called modeling. And domain is basically you decide how to structure your data into different tables and so on. So if you are considering to develop a system, let's say to have admissions in a school, then what kind of tables do you need? For admissions in the school, you need definitely students. But will you store information of students all in one big table, or you would rather choose multiple tables for different faculties? Because if you have a really big university, you might have, let's say, a science faculty, you might have arts faculty, and you might have business faculty. Now all these faculties will have different buildings, different number of teachers, different admission criteria, right? If you are given this problem of developing an admission system, how would you do it? That's called domain modeling. It can be applied to any problem. Then you're given a domain and you're going to model it into different tables. Now when you do it, remember from the first lecture of the database, so in the week 1, we discussed the concept of entities. And that's very important because a lot of students forget about entities and instances. And I'm just going to revisit it now, because entities are opposite to abstract. They are abstract concepts. They are opposite to concrete. And it is important for domain modeling because science, arts, and business, you cannot have them as entities or as a table. They are merely instances of faculty or types of things, right? Because science is the name of faculty, arts is the name of faculty, business is the name of the faculty. What you can have as an entity is the faculty, and the faculty entity only makes sense if you name the faculty. Like what kind of faculty, what is the stream, or what is the field. Does student want admission for science faculty or arts faculty or business faculty? So these are all instances, and it's very easy to think that these instances can be tables, and I have seen students make this mistake. So that's why I'm saying making the mistake myself, that science, arts, business faculties might seem like entities, but they are actually instances of the faculty table or the faculty entity. So for domain modeling, this is very important to realize what is the entity and what is the instance. Once you figure out what is the entity, then you can associate attributes to it. For example, in the admission system, if you have student as the entity, which is a very good example of entity because student is abstract, and individual student who is applying for the admission is the instance, and each student will have certain attributes, which is name, gender, date of birth, and so on. These are the attributes. These must be the columns. So when you are doing domain modeling, you figure out what are the attributes of the entities. In other words, what are the columns of the database tables. Then you figure out, can one student apply to multiple faculties? Can one student apply to multiple universities? So is the relationship between student and university is one to many, or faculty is one to many? Then you might have an entity called course. Can student apply for multiple courses? Can one course have multiple students? Then if you extend this admission system to actually university management system or course or examination system, you might have an entity of teachers, where one teacher has multiple students or one student also has multiple teachers. Then should you have many to many relation? What about exams? So when you do domain modeling, you need to figure out if you want to have such many to many relations, or you want to restrict it to one to many relation, and then only force one student to have multiple teachers but not the other way around. But then how will you manage teacher and course? One teacher teaches multiple courses. One student takes multiple courses. So where should be the foreign key? Where should be the primary key? And so on. And this domain modeling is a very, very big topic, and it also has to do with normalization. Now the normalization is kind of advanced topic, and we'll try to cover it next week. But I want you guys to do a little bit reading on entities and attributes, and I'll come up with a homework that will make you think a little bit about how to design a database. And I think that's it for this week. I think we covered almost everything I wanted to cover. primary key, foreign key. We saw primary key is the column that uniquely identifies the row. Foreign key is the column that we borrow from another table. It is a constraint. Composite key is the key that consists of more than one column. One-to-one relationship, we don't need a special provision. One-to-many relationship, we use the primary key of the one table into the many table. For many-to-many relationship, we create a new table that contains a composite primary key. Joins, we saw the comma or the cross join. We saw the inner join with the on keyword. We saw self joins and left join and right join. The example of manager and reporting, we saw two aggregate functions, sum and join. We saw distinct, which gives you the distinct rows. We saw group by clause that groups by a certain column, and having clause, which works as a where for filtering between the rows given by the group by clause. And we saw in extremely brief what is entity relationship diagram, where you basically draw entities and columns and see what's the relationship between them as one to many, many to one, and you mark primary and foreign keys. Well, that's about the week 2 content. I'll probably see you guys next Sunday, or we'll do another online session.